Introduction to Nmr. Nuclear magnetic resonance is a spectroscopy technique which is based on the absorption of electromagnetic radiation in the radio frequency region 4 to 900 MHz by nuclei of the atoms. Protonuclear magnetic resonance spectroscopy is one of the most powerful tools for elucidating the number of hydrogen or proton in the compound. So this is the instrumentation. It has detector, RF transmitter, main controller and printer. Next, I pass to the next presenter.
Assalamualaikum and a very good morning. For the next part, we will take a look at the process of NMR spectroscopy. First thing we need to do is sample preparation. The recording of the sample must be done in a solution. To avoid interference from the H nuclei of the solvent, special deuterated solvents are used. Deuterated solvents have 2 H deuterium nuclei instead of 1 H. For example, deuterated chloroform can be used to dissolve fats and oils for NMR spectroscopy. Next, we will take 10 mg of our sample and place it in our NMR tube. Then the sample was dissolved in 0.7 ml of the solvent we picked earlier. Then the tube was closed with its cap and label. Then the tube need to be shaken to ensure all sample has been completely dissolved. Then we will need to do some analysis preparation. First thing first, the tube need to be inserted to a spinner. Then the outside of the tubes must be cleaned with propanol and soft tissues to avoid any fingerprints. Then the spinner must be placed in a sample depth gauge to ensure the bottom of the tube is not inserted too far into the probe to avoid damaging our NMR spectrometer. Then to begin our sample analysis, the sample was placed in the spectrometer. After completion, the obtained spectrum can be processed. This is the example of NMR spectra of some sample oils. Then I will pass to the next presenter. Thank you.
Okay, I will continue with the advantages and disadvantages of NMR. Okay, first advantages of NMR is non-destructive analysis. So it means that NMR spectrometers don't harm the sample. NMR not only observe a variety of molecules of different size, but they can observe them over and over again. And then second is NMR require very small sample volumes to analyze. And then NMR spectrometers can observe different phases. It means that the NMR spectrometer capable to observe both solids and liquids compared to other instruments that are limited only to one type only. And then NMR is lower maintenance cost and highly detailed and accurate data. By triggering an energy transfer between an external magnetic field emitted by the spectrometer and electromagnetic signals generated by nuclei, so we can access a treasure trove of data. Okay, and then next is the disadvantages of NMR. First is low sensitivity. NMR spectroscopy is highly versatile, but it often fails due to its low sensitivity. This is due to the magnetic resonance aspect of NMR, which has weak interaction energies involved. To overcome this limitation, sensitivity can be improved to some extent by optimizing the hardware used for NMR experiments. For example, the signal to noise ratio can be improved by raising the concentration of the target analyte or by encouraging quicker recovery of magnetization of spins. And then next is magnetic field drift. Drift in the magnetic field affect all magnetic resonance technology. It can lead to spectral peaks broadening and line shapes being distorted, making interpretation of NMR results very difficult. And then next is NMR is expensive instrument, and then lastly is tendency for spins to align with fields is weak. Even at equilibrium, most spin are random. To overcome this problem, we can use pseudo-pure states method. So that's all from me. I will pass to the next presenter.
Okay, my name is Nurul Zulaika binti Roslan and my metric number is 202916. So I will proceed with the high performance liquid chromatography analysis. So high performance liquid chromatography, HPLC, is the most common analytical separation tool that used in many aspects for drug manufacture and research. And usually HPLC used for qualitative and quantitative analysis of unknown mixture, and also for the separation of mixture for later analysis. In chromatography, a small volume of a mixture of chemical is passed through a column using a solvent, and different molecules exit the column at different times. And this is what we call separation. The separation of a compound involves its physical interaction with a stationary phase and a mobile phase. In chromatography, a tube is filled with stationary phase, typically surface modified silica particles or silica gel, and a mobile phase solvent is passed through the system. In HPLC, the stationary phase is extremely small and it is packed in a stainless steel tube, and solvent is pumped through the system under high pressure. A small high surface area stationary phase maximizes the interaction between the substance to be separated and the stationary phase, which results in a better separation. So there are two types of HPLC, which is normal phase and reverse phase. For normal phase, the column is filled with tiny silica particles and a non-polar solvent. For example, is hexane. A typical column has an internal diameter of 4.6 millimeter or smaller and a length of 150 to 250 millimeter. Non-polar compounds in the mixture will pass more quickly through the column, as polar compound will stick longer to the polar silica than non-polar compounds will. And for the reverse phase, the column size is the same. The column is filled with silica particles which are modified to make them non-polar. A polar solvent is used, for example, a mixture of water and alcohol such as methanol. Polar compound in the mixture will pass more quickly through the column because of a strong attraction occurs between the polar solvent and the polar molecules in the mixture. So this is the instrument in HPLC. So the primary part of an HPLC are solvent pump, injector, column, and detector. And each of these components are connected in a series to each other by steel tubing. The pump controls the flow of the solvent through the system. Upon leaving the pump, the solvent enters the injector and then pass through the column and finally through the optical unit of detector. Injector allows a convenient and controlled introduction of sample directly onto the column, while the detector indicates when a particular other light elutes. If desired, the separated components can be individually collected for later analysis. So that's all from me. I will pass to next presenter.
Now, let's see the process of HPLC. Although gas chromatography is predominantly used for fatty acid analysis, HPLC is used in handling of less usual samples to avoid the degradation of heat-sensitive functional groups and also for micro-preparative purposes. Reverse phase chromatography is one of the most common form of HPLC, in which the stationary phase is non-polar and the mobile phase is polar. In reverse phase chromatography, the stationary phase can be made up of organochlorosilane or also octadecylsilane, and the mobile phase is made up of acetonitrile or methanol. So if you look at this animation, it can be seen that the solvent is flowing from the mobile phase, which is polar, to the stationary phase, which is non-polar hydrophobic. In reverse phase chromatography, if free fatty acids are analyzed, a little acetic acid can be added to ensure sharper peaks. Greater sensitivity is possible if phenaceal or related derivatives of fatty acids are prepared for detection at higher wavelengths. Fatty acids are separated both by chain length and also by the degree of unsaturation. There are also other analyses that can be done for fatty acids, and first we'll look at adsorption chromatography. So adsorption chromatography is in which the columns of silica gel in HPLC, it can be used for the analysis or isolation of fatty acids with polar functional group, especially oxygenated components such as hydroperoxides. Isomers differing in the position of hydroperoxy or hydroxy groups on an aliphatic chain can be separated by using this adsorption chromatography. Next is chiral chromatography. So the fatty acids that contains enantiomeric functional groups and also hydroperoxy or hydroxy groups can be resolved on a variety of commercial chiral stationary phase. Chiral separations is usually possible by gas chromatography, but then it appears to be less effective in general. The next one is silver ion chromatography. The pi electrons of double bonds in the fatty acid residues of lipids react reversibly with silver ions to form polar complexes. The greater the number of double bonds, the stronger the complexation effect. Lipid samples are usually applied to a plate, and this is developed with a suitable mobile phase. So the fully saturated lipids do not form complexes and will migrate to the top of the plate. Those containing one monoenoic fatty acid residue will come next, and the components of increasing unsaturation then follows. Okay, I'll pass to the next presenter.
Okay, my name is Nurul Izzah binti Burhanuddin and my metric number is 202257, and I will continue to present about the advantages and disadvantages of HPLC. HPLC offer rapid and high efficient method compared to other chromatography techniques such as TLC. HPLC is extremely quick and efficient because it uses pump rather than gravity to force liquid solvent through a solid adsorbent material. The different chemical components will separating out as they move at different speed, and the process can be complete in roughly 10 to 30 minutes. Second is automated operation, and because it is largely automated, basic HPLC can run forms with minimal training. Next is it is highly reproducible, and lastly, it is highly precise method to recognize certain chemical component in a sample. In general, HPLC is versatile and extremely precise when it comes to identify and quantify chemical component. With many steps involved, the precision of HPLC high and it delivers high resolution. For disadvantages, the disadvantages of HPLC is the separation in HPLC has less efficiency than GC. This is because of the speed of HPLC and it relies on different polarities of compound. Two compounds with similar structure and polarities can exit the chromatography apparatus at the same time or nearly same time. And this is known as co-elution. Co-elution will make the process to determine which portion of mixture elute at what point will be difficult. Second, HPLC can be an expensive method because it requires large number of expensive organic, it needs power supply, and regular maintenance is required. Develop an HPLC apparatus, even though it is much more efficient, but it is much more costly than other chromatography technique. Third, the HPLC pump process reliability relies on cleanliness of the sample, mobile phase, and proper operation of the system, and it can be complicated to troubleshoot the problem. And lastly, HPLC can have low sensitivity to volatile compounds. That is all from our group. Thank you.